AI to his research. The research title is Enhancing Linear Accelerator Operational Efficiency with Predictive Model for Downtime and Interlock Events. This would be presented by Mr. Eshtiaqul. Please, Mr. Eshtiaqul, start your presentation.
Assalamu alaikum and good afternoon, everyone. First, I would like to thank the moderator, sir, session chair, and the organizer of this conference for the opportunity to present the work. I'm Eshtiaqul and I'm honored to be here today to share my recent work on enhancing linear accelerator operational efficiency using predictive model for downtime and interlock event. So, as medical physicists, we all recognize how critical uptime in radiotherapy delivery. Even minor interruptions, whether due to interlock triggers or unexpected system faults, can associate into delayed treatments, workflow, bottlenecks, and increased stress for both staff and patients. Traditionally, we approached these issues reactively. So, responding to faults after they occur, but with the increasing integration of data system and machine learning, we are now in an era where we can shift from reactive to proactive. So here we can see that many low and middle income countries have limited access to radiotherapy units, with some countries only having one unit to serve over 20 million people displayed here. And for plot of component codes that for LIDAC, a demarcation is added to mark the component areas that contributed 80% of the machine costs. The areas that are present in the top 80 of the cost for the plot is KV, MV, Thyrotron, ion chamber, MLC, and PCB, printed circuit board. So to develop a machine learning model using deep learning algorithm that can predict the interlock for LINAC is our first priority. And then to develop a machine learning model that can predict the downtime for predicted interlocks. And to accurate predict the interlock and downtime, we need to create different types of machine learning models with different algorithms and compare between them. So in this presentation, I will walk you through how we control and analyze the interlock and downtime data from linear accelerators, the development and validation to predict models to forecast these events. And our goal is not just to predict when machine might fail, but to provide medical physicists with tools to optimize service scheduling, reduce unscheduled downtime, and ensure continuity of the patient care. So we know what a linear accelerator is and what machine learning is. So I am going to my workflow. So I worked in the Square Cancer Center for these downtime and linear accelerator research. And we use different types of model like support vector regression, random forest regression, decision tree, elastic net regression, and lasso regression, Bayesian regression for comparing the models. So my workflow is I load the data from the spreadsheet and then I explore the exploratory data analysis, then data cleaning, labeling, and training and testing the generation using sliding show window, training the LSTM model for interlock prediction, then test the model and we can find the top two predicted results. So after importing the initial libraries, conducting general exploratory data analysis, along with the plotting, we applied the level encoder to interlock the column. Then we proceeded to the prepare build and train the LSTM model. It's called long and short term model, followed by the evaluating its performance and predict the next interlock. And this is the workflow for the downtime. After importing the libraries and performing EDA along with plotting, we converted the time from hours to minutes and apply level encoding. Next, we split the data into training and testing models and visualize the predicted and actual values using bar charts, scatter plots, and residual plots. Finally, we validate the best model using k-fold cost validation. So this figure shows the initial data frame of unique categories and total count of the interlock data. And here is the histogram of recovery data and interlock events data. And as you can see, the model was trained with 300 epochs, and the test accuracy for predicting interlocks is 84% with top two predictions. And this is the downtime data summary and visualization. And this is the plot showing predicted and actual downtime result visualization and residual plots for support vector regression. This is for the random forest. This is for the decision tree. This is elastic net regression. And this is for the lasso regression. And we find the better result in Bayesian regression. So the Bayesian regression model demonstrated the promising result, providing accurate prediction with minimal error. It was evaluating using cross-fold cross-validation, a method that split the data into k subsets, training the model on different subsets while validating it on the remaining ones, ensuring the reliable performance across multiple iterations. The first goal was to predict interlock and downtime events for the Branian Clinic Medical Linear Accelerator at Square Hospital using available data. And the last one is the Bayesian regression was the most accurate, followed closely by the elastic net and lasso regression. And the sixth model were developed for downtime prediction with Bayesian regression, and the highest accuracy of 98.21% and the mean squared value of 0.0179 based on k-fold cross validation is measured. So there's some limitation. Automatically generated logs are more reliable than handwritten logs, reducing human errors and improving model. And further work is currently underway, including a development of graphical user interface (GUI interface). And additionally, ongoing research is being conducted to improve the dataset and enhance the overall accuracy and prediction of the system. So in conclusion, we can say that the work demonstrated the success of machine learning model and predicting interlocks and downtime events for Varian Clinic Medical Linear Accelerator at Square Hospital. And LSTM model showed notably accuracy and predicting interlock events, proving its effectiveness. And Bayesian regression is far better than other models for our downtime predictions. This is my references. Thanks all.
Thank you, Mr. Eshtiaq, for your innovative ideas. Thank you. Now, I'd like to